another question, still on mix and yield variances. Recall I mentioned it in the previous video that I will be solving a new question that will put a different dynamic in what we've been doing, and that's talking about the loss in percentage during production. So you can take 1 or 2 minutes to go through the questions quickly, then you can replay the video to see how I am going to address this question. And this is the major difference in this question. I'm talking about this line, 10% process loss. It is possible you have an exam question on yield and mix variances with this type of twist, and you need to learn how to adapt this to the understanding that you have. And why is this relevant? This will be extremely important when you are computing your standard usage, your standard quantity that you expect to be used during production. Because if there is 10% loss in material during production, it means that your output only represents 90% of what it should have been. So which means that the material that you have used to produce that output is actually 90% and 10% has been wasted. So in terms of consumption, it's going to be 100% because we consume 100% of materials. The only difference is that 90% went straight into product and 10% went down the drain. So that is what we want to do. Yeah, the question wants us to calculate the mix and yield variances, but I'm going to do more than that for this question. So I will start from revising the usage variance with you. Yeah, so I will start with the usage variance, which is the overall usage variance. Remember that usage variance is what we usually break down into mix and yield variance. Yeah, so let's do usage variance first. And remember, what's the usage variance? We're just saying that have we consumed more than we should have consumed? And the valuation will always be the standard price. So which means we're saying this will be equals to actual quantity that we used, that is what we consumed, minus what we are supposed to consume. Then we'll value it at standard price. That is exactly what we're talking about when anytime you try to compute usage variance. So I'm going to have all the materials X and Y, Z, X, Y, and Z. And we'll have the actual quantity. We're going to have the standard quantity, the standard price, and we're going to have the variance, which is where we're expecting. So let's work this. Actual quantity is easy. It's been provided in the question 680, 190, and 130. So we have 680, 190, and 130. Yeah. I'm coming back to this standard quantity because that is where we need to do some working. So I'm going to put working 1 here. We'll come back to that. But let's put the standard price. Standard price is the planned price, which has been given as 0.4, 0.6, and 1. Right. So we need working 1. So let's do working 1 quickly, which is where we need to calculate the standard quantity for X, Y, and Z. And there are 2 approaches to this. Yeah. So the first approach that I'm going to show you is you can think about it from the output perspective, which means that if we have produced 920 bags, then how much should we have produced if there was no material loss of 10%? So that is what we expected, because we're saying that 90% is the 920 that we have, because there was 10% loss. So what is 100%? It means that the total output would have been 100% of that 920 divided by 90%. Yeah. So which means if there was no material loss, we should have produced 1,022 bags of fertilizers. And if that is the case, what portion will be X, what portion do we expect to be Y, and what portion do we expect to be Z? And that has been given here because the standard proportion of our materials for the overall product is in this ratio of 70, 20, 10. So which means X will just be 70% of that, and all other product will follow suit. So Y will be 20% as well. of what we expect as outcome, and Z will be 10% of that. That is one way of doing it. Yeah, sorry, the standard quantity, so it should be here. Let's put it here. Yeah, this is our variance column. Yeah, that's another way, one way of doing it. But there's another way of doing it, which is looking at it from the input perspective. So let me just say another method. Yeah, and that another method is just saying that 920 we produced, and we know that XYZ will be in that proportion of 70%, so 0.7. Or let me just put 70%, 20%, and 10%. Yeah, so which means that out of 920, X will have contributed that proportion, and Y would have contributed all of that proportion, and Z like that. However, this 644 only represented 90% of X. So we need to get 100% of X. So this is 90% of those materials, but we need to know 100% because that's our total consumption. So if that is 90%, it means that 100% will be this, multiply by 100%, then divide by 90%. Let me make this absolute so that I can just drag down easily. Yeah, so you can see 715, 715. You will get the same answer for all of them. And that is it, you can see. So depending on whatever method you feel more comfortable with, I just like to show you different ways of doing things because it's important that it looks simple enough for you to be able to understand. Yeah. So now let's do the variance, which is pretty easy. That is looking at actual quantity minus standard quantity. Then we're going to value it at the standard price. And that is it for X, and we have the same for Y and Z. And the total is our overall usage variance, which is that. So X is the adverse of favorable, check it. Actual is less than standard, so that is favorable. Similarly, the next one is favorable, and Z used 130 against expected of 102, so that's adverse, and that is why our final will be adverse because 27 is more than 22 thereabout of favorable. So that is it for the overall usage variance. But remember, that is not what the question wants us to do. What the question wants us to do is to calculate mix and yield variances, which means this 4.89 adverse, we need to split it into both mix and yield variances. And let's see what that looks like. So, I remember what I said. For both mix and yield variances, you just need to think about new column to be introduced. And that column is you asking a question of what if we had stuck to our standard proportion? Because if you look at the actual consumption here, 680, 190, 130, that is a total of, let's see, what total is that? It was given in the question anyway. That is 1,000 actually. Yeah. So this 1,000 means that X has been used in proportion of 68%, 19% for Y, and 13% of Z. However, our expectation, our plan was to consume them in 70, 20, 10. So we have consumed them in different proportion. So we want to check using mix and yield variances. What is the impact if we had stayed with the planned proportion of 70, 20, and 10? And that is the new column that you always have to introduce. And that is what I'm going to introduce now. And I will call it, let's call it standard, let's call it actual quantity at standard proportion. That's what we're going to call it. So let's put that here. So we have X, Y, Z, X, Y, and Z. And we have the standard proportion, which is 70, 20, 10. We already know that. I can as well put that here. And we know that the total actual consumption was actually 1,000. So if we had stuck to our standard proportion for that 1,000, what would have been our consumption for each material? That is what we want to put in. And that is the new column that we always add for both yield and mix variances. The only difference between mix and yield is the comparison. So for mix, we're going to be comparing with actual quantity. And for the yield, we'll be comparing with the standard quantity. That is the difference. So for mix, we are doing now, we know our actual quantity. I can just copy that here because it's there already. Yeah, and also the total should give us 1,000, right? And valuation is always at the standard price, as I always remind you, standard price. We know the standard price, 0.4, 0.6, and 1, as we have it here. So I'm just going to copy it as well and put it here. You can see these are information that's readily available. Then we can compute our variance for each of those materials. And that means for X, we're going to have actual, this is our actual, minus standard, multiplied by the standard price. Yeah, and we have minus 8. The same thing we will do for all the other materials. And we can get our total, yeah, which is sum of everything. And that is 16. But is it adverse? We need to find out whether it's favorable or it is adverse. So for X, actual quantity is less than the standard, so that is favorable. We like that because we consumed less. The same thing for Y, we consume less because the less we consume normally, the cheaper you will expect, right? However, for Z, it's adverse, right? And that is why the net will be 16 adverse, because the total consumption for Z has led to a huge advance of 30. That is too big for the savings on X and Y to actually compensate for. So the question is, why do we have adverse variance? So what we'll say is Akram must have used more expensive material Z than it was meant to use. Yeah, because we can see that it was meant to use 100 if we have stuck to our standard proportion. However, we have used 130. Yeah. And so that extra cost definitely outweighed the savings from the cheaper materials that we actually underused. So you can see X and Y are more cheaper, 0.4, 0.6. Yeah. And we have used less than we are actually meant to use under standard proportion. However, the extra 30 consumption that we have at a more expensive price is too huge of adverse variance. And unfortunately, that gave us 16 adverse in entire X consumption. Yeah. So that's what I've tried to put in that summary for you. Okay. Now, let's look at yield variance, because we cannot conclude that this is good or bad until we see the impact on yield. Remember, yield is about the output, so you can sacrifice mix variance for an excellent yield variance, because yield will always be about the output, which is what the customer gets. So if you want to give the customer something much better and you think that changing the standard mix will be able to achieve that, why not? But let's find out. So for yield variance, remember, this new column, we're still going to bring it in because we want it. It is the standard proportion of consumption, like we have said, is going to be the same. Yeah, for both mix and yield variances. So I'm going to keep that, but like I said, instead of comparing with actual quantity, we're going to be comparing with standard quantity. So in fact, let me just take the whole table, because it's the same thing we want to do, exact thing. So we need all of these, but this will now be standard quantity. We're still going to use standard price to evaluation, but this will be different. We've computed standard quantity in working one. So I'm going to reference that here as well, because I'm going to copy it now. Standard quantity, we have it here in working one. So I'll just put it here. Yeah. So that's the standard quantity that we expect, right? If we have done what we were supposed to do based on the process, loss, and all of that, right? So, and you can see the variances as well, but let's check which one is adverse or favorable. Yeah. Now, this is our actual consumption, remember 1,000, and this is full standard. So this is more actual. So we're going to use this as actual, and that means we are consuming less than the standard, and that will be favorable for this. Likewise for X and Y and Z. So all of them favorable, and that means 11.11 is going to be favorable. Yeah, so which means yield variance is actually nice and good. However, if you see the variance we had for mixed variance is actually 16 adverse, so which is much more than the 11 favorable we have. So if you check the net, actually, that is what we are talking about when we spoke about overall variance here of 4.89. That's overall usage variance, and that's how to actually see that what you have done makes sense, because the net of those two must give you your usage variance. And that is it for yield variance. Now, I won't stop there as well, because I'm going to still do a revision for you on price variance. Yeah, remember, I've told you it's not any different from what you know for price variance. There's nothing totally different, no difference at all. But if you see a question like this, please don't use cumulative consumption. Make sure you do for each material separately and you add it together. Price variance is about asking yourself this question: did I pay a different price from what I planned to pay for those materials that I bought? So which means that I'm going to be talking about actual price, because that is what I paid, compared with my standard price, that is what I planned to pay, and what I bought, and that is actual quantity. So it's just as simple as that. So we need actual quantity, and we need the standard price and the actual price. So actual quantity, we have it somewhere here, so I can bring it down quickly. Standard price as well, we know it is 0.4, 0.6, and 1. It's here. I can put it here. And the actual price, we have it in the question. The actual price, so we have the actual price, and that is 0.45, 0.62, and 0.95. So I'm going to put it here, 0.45, 0.62, and 0.95. So with that, we can get our variance, which is equals to the actual price that we paid minus standard price that we should have paid, multiplied by the quantity that we bought for each of those products: material X, material Y, and material Z. And the total price variance can also be computed by adding everything together, and that is 31.3. But for us to know whether 31.3 is adverse or variable, we need to check for each of them. So for X, we paid more than we were meant to pay, so that is adverse. For Y, the same thing, that's adverse. But for Z, we actually paid less than we should have paid, and that is favorable. So that means that we have about 37.8 adverse versus 6 favorable, and this has to be adverse. And this is the problem. Overall price variance is adverse, overall usage variance is adverse. So total material variance is actually about 35, 36 adverse. We had this 4.9 with this, that's about 35, yeah. So that is adverse. And who are you going to blame for that? Is it production manager? Is it procurement manager? And that is where your understanding of variances beyond competition is also important, because you might be expected in exams to discuss. So you need to be able to explain various possibilities. Why do we have 31.3 adverse variance for price? Yeah, and your possibilities will be, number one, is either we did not negotiate price for X and Y properly, and we have paid so much for it, more than we plan to pay, or we have bought them in a very competitive market, maybe expensive market, or we decided to even go for a better quality than we planned to get, maybe for a sacrifice, for a better yield, for a better product. Yeah, but we'll need to see how the yield has increased our sales or our profitability or customer satisfaction before we can conclude all of that. Or maybe Z has even been bought from a cheaper market or a fake Z, which means substandard quality of Z has been bought, which will not be good, because if that is done, then there might be more wastages, and that might also impact on yield or customer satisfaction. So those are the discussions you could put, because there is no one way or one answer to everything. You just need to demonstrate understanding by discussing various possibilities. And that is it for Akram.